Good day, everyone. I am Igarlova Jessa, and my assigned topic is all about the history of moon's exploration. It talks space age exploration to show us how the moon is connected to human existence on a very fundamental level. The robotic exploration of the moon, the shocking launch of Sputnik 1 in October 1957. The moon changed from distant silver disk in the sky to a real place. So, this image of Sputnik 1 was the first artificial Earth satellite. It was launched into an elliptical low Earth orbit by the Soviet Union on October 4, 1957 as a part of the Soviet space program. The Soviets struck the first flying Luna 1 by the moon in January 1959. They followed the success with a number of the robotic probes, culminating later the same year with Luna 3, which photographed the far side of the moon, never visible from Earth. From these early poor quality images, they discovered that the far side has surprisingly few planes that surprise with the dark, smooth mirror planes that cover about a third of the near side. Another surprise would soon follow. So if you ask what is space probes or robotic probes used for, it is an unpiloted, unmanned device sent to explore space and gather scientific information. Launched from Earth with a set of scientific instruments and tools used to study the atmosphere and composition of space and other planets, moons, or celestial bodies. In response to the 1961 flight of Soviet cosmonaut Yuri Gagarin, President John F. Kennedy committed the United States to landing a man on the moon by the end of the decade. The Apollo program greatly accelerated interest in exploring the moon. To ensure that human crews could safely land and depart from the lunar surface, it was important to understand its environment, surface, and processes. At the same time, the robotic precursors would collect valuable information constituting the first scientific exploration of another planetary body. America's first step was the Ranger series of hard landers. These probes were designed to photograph the lunar surface at increasing levels of detail before crashing into the surface. After several heartbreaking failures, Ranger 7 succeeded in sending back detailed television pictures of Marinobium, or Sea of Clouds. In July 1964, from the Ranger probes we discovered that craters, those strange holes that paper the lunar surface, ranged down in size to the very limits of resolution. Micrometeorite bombardment has ground up the surface rocks, creating a fine powder called regolith. Two more Ranger spacecraft flew to the moon, culminating with the 1965 live from the moon television images from Ranger 9, carrying into the spectacular lunar crater Alphonsus. We got much closer look at the moon's surface in early 1966. Again, the USSR led the way by safely soft landing the robotic womanized spacecrafts on the mirror plane, Oceanus Procellarum. It found the surface to be powdery dirt, churned with a few rocks, but strong enough to support the weight of a landed spacecraft. In May 1966, the United States followed with the landing of the complex robotic spacecraft, the Surveyor 1. It sent television pictures back to the Earth, showing in the surface and its physical properties in detail. Later Surveyor mission collected physical data on soil properties, including its chemical composition. Analysis of the lunar surface showed that the dark Maria had a composition similar to terrestrial basalt, a dark iron-rich lava, while the highlands near the very fresh Reed crater, Tycho, were lighter in color and strangely enriched in aluminum. This led to an astonishing revelation about the moon's early history after the first physical samples were later returned to Earth by the Apollo 11 crew. Oceanus Procellarum, a vast dark patch visible on the western edge of the moon's near side, has long been a source of mystery of planetary scientists. Some have suggested that the ocean of storms is part of a giant basin formed by an asteroid impact early in the moon's history. So, these are the images of succeed launched space robotic machines. The final robotic missions mapped the entire moon from orbit for the first time and obtained extremely high-resolution pictures of potential landing sites, certifying their safety for the Apollo missions to follow. This U.S. lunar orbiter series conducted 5 mapping missions, whereby boulders as small as a couple of meters could be seen. They also obtained amazing views of scientifically interesting targets, such as the first pilot's eye view of the large, brightly rayed crater Copernicus, dubbed the picture of the century by news reporters. More pictures of the century were soon to be obtained by people walking on the moon. From these robotic missions, we learned that the moon was cratered and pit at all scales. The surface was powdery dust but strong enough to support in the weight of people and machines. The moon had no global magnetic field or atmosphere and was made up of common rock types, similar to those found on Earth. Now the stage was set for the next giant leap in understanding lunar and planetary history. Apollo, the humans follow. Apollo was the finest hour of America's space program. In just 8 years, we had gone from zero human space flights capability to landing men on the surface of the moon. From these missions, scientists developed a new view of the origin and evolution of the planets and of life on Earth. The 1968 Christmas time flight of Apollo 8 was a milestone. Humans left low Earth orbit and reached the moon, circling it for almost a day. For the first time, people gazed on the moon from orbit. They found it desolate and gray, but saw nothing to prevent journeying the final 62 miles to the surface. In May of 1969, Apollo 10 orbited the moon testing the lunar lander. It was a dress rehearsal for the manned landing to come. Each of the Apollo missions and the astronauts who remained in the orbiting command module during the subsequent landed missions took hundreds of high-resolution photographs of the moon's surface. Their visual observations added to the burgeoning knowledge of lunar geology. In a harrowing descent marked by the program alarms from an overloaded computer and freezing foil lines, Neil Armstrong and Buzz Aldrin in Apollo 11 safely landed in Mare Tranquillitatis, or Sea of Tranquility, on July 20, 1969. We walked on the moon for over 2 hours, collecting rocks and soil and laying out experiment packages from the Apollo 11. We learned that the dark Maria are ancient volcanic lavas having crystallized over 3.6 billion years ago. Lunar samples are similar in chemical compositions to Earth rocks, but extremely dry, with no evidence for any significant water on the moon past 3%. Small bits of white rock were found in the soil, blasted to the site from distant highlands combined with the earlier results of Surveyor 7. Chemical analysis at the crater Tycho. Scientists reasoned that the ancient moon had been nearly completely molten, covered in a layer of liquid rock. This idea of an early magma ocean has since been applied to all the rocky planets. Micrometeorite bombardment drowned out the bedrock and gases from the sun were implanted on the surfaces of the lunar dust grains, while preserved on the moon. Most of this ancient history has been lost on our geologically active Earth. Mare Tranquillitatis is a lunar mare that sits within the Tranquillitatis basin on the moon. It is the first location in another world to be visited by humans. The mare material within the basin consists of basalt form in intermediate to young age group, the Upper Cambrian epoch. In November 1969, Apollo 12 touched down in Oceanus Procellarum, or Ocean of Storms, near the previously landed Surveyor 3 spacecraft. This mission demonstrated our ability to precisely land on the moon, a skill critical for navigating to future sites in the highlands and rugged areas. Astronauts Pete Conrad and Alan Bean explored the site in 2 moonwalks. They collected over 75 pounds of samples and deployed a nuclear-powered experiment package. Lavas from this landing site are slightly younger than those of Apollo 11, but still over 3.1 billion years old. The Highline component here is different from that of the first landing. It has unusual enrichment in radioactive and rare earth elements, suggestions that the moon's crust is literally variable and complex. As a bonus, the crew also returned a light-colored soil, possibly part of a ray cast off and flung outward during the formation of the distant crater Copernicus. 186 miles north of the landing site, dating of blasts from this soil suggests that Copernicus is only 900 million years old, ancient by Earth standards, but one of the youngest major features on the moon. The explosion of an oxygen tank on Apollo 13 prevented it from landing on the moon. The three-man crew returned safely to Earth. A memorable saga closely followed around the world. Apollo 14 was sent to a highland site east of Apollo 12, near the ancient crater Fra Mauro. This site was chosen to collect rock blasted out from deep within the moon by the formation of the giant Imbrium impact basin, a crater over 620 miles in diameter and situated 3,723 miles north of landing the site. Astronauts Alan Shepard and Edgar Mitchell conducted 2 moonwalks on the lunar surface. Towing a pull cart filled with tools, they returned over 95 pounds of rock and soil. Samples from the Fra Mauro Highlands are breccias, or complex mixtures of ancient rocks. Broken and crushed by the giant impact created the Imbrium Basin. From these samples, scientists learned that the Imbrium impact occurred more than 3.8 billion years ago, before the dark Merly lavas flooded on the moon's surface, but well after the formation of the moon's crust over 4.4 billion years ago. After this third landing, a new picture of lunar evolution was emerging. The moon was not a simple lump of cold meteorite, nor was it an active volcanic inferno, but a planetary body with its own complex, subtle history. In July 1971, with Apollo 15, NASA began the first of 3 what were termed G missions, long-duration stays on the moon with a greater focus on science than had been possible previously. Apollo 15, whose lunar module Falcon spent 3 days on the lunar surface, was the first mission to use a lunar rover, a small electric cart that allowed the crew to travel many kilometers away from their landing craft. On 3 lunar rover excursions, Dave Scott and Jim Irwin explored the beautiful Halley Apennine landing site, a valley at the base of the main rim of the huge Imbrium Basin that included both Mare and Highland rocks. The crew returned the Genesis rock, composed almost entirely of a single mineral, or plagioclase feldspar, representing the most ancient crustal rocks on the moon. They also found smaller fragments of an emerald green glass, formed when magma from the deep mantle explosively erupted through the crust in a spray of lava. This sampled the Mare bedrock at the edge of Hadley Rille, a giant canyon and ancient lava channel formed over 3.3 billion years ago. The Apollo 15 mission obtained over 80 kilograms of samples, and its command module carried chemical sensors and cameras that mapped almost 20% of the moon's surface from orbit. Apollo 16 was sent to the ancient crater Descartes, deep in the lunar highlands in April 1972. Astronauts John Young and Charlie Dock spent 3 days exploring the site. They traveled over 18 miles and collected more than 206 pounds of samples. They deployed and operated the first astronomical telescope on the moon. The Highlands rocks, almost all breccias, attest to a long and complicated history of repeated impacts from space. Ancient crustal rocks similar to the Genesis rock of Apollo 15 were also found. One puzzling observation by the crew was the measurement of a very strong magnetic field on the surface. Even though the moon has no global magnetic field, some lunar samples have remnant magnetism, suggesting that they cooled in the presence of strong fields. Although We still do not understand the lunar magnetism. With the flight of Lunar Prospector 26 years later, the Apollo 16 result would become a little clearer. The last human mission to the moon to date, Apollo 17, was sent to the age of Mare Serenitatis, or Sea of Serenity, another combination Mare Highland site in December 1972. Gene Cernan and Jack Smith, the first professional geologists sent to the moon, spent 3 days thoroughly exploring the Taurus-Littrow Valley. They returned over 242 pounds of samples and deployed a set of new surface experiments. They made startling and significant discoveries. The crew found 3.6 billion-year-old orange volcanic ash from the mountains, the returned crustal rocks and complex breccias created during the impact that the form of Serenitatis descended almost 3.9 billion years ago. Lavas at this site are over 3.6 billion years old, documenting at least 700 million years span of lava flooding in the moon. Taurus-Littrow is a lunar valley located on the near side of the coordinates 20.0 degrees north, 31.0 degrees east. It served as the landing site of the American Apollo 17 mission in December 1972, the last crewed mission to the moon. The robots returned, Clementine and Lunar Prospector. In the 1990s, two small robotic missions were sent to the moon. For 71 days in 1994, the joint NASA Strategic Defense Initiative Organization Clementine mission orbited to the moon, testing sensors developed for space-based missiles defense, as well as mapping the color and shape of the moon. From Clementine, they documented the enormous South Pole Aitken impact crescent, a hole in the moon, 1,616 miles across and over 8 miles deep. This basin is still so large, it may have excavated the entire crust down to the mantle. The color data from Clementine combined with Apollo sample information allows them to map regional composition, creating the first true rock map of the moon. Finally, the Clementine gave them a tantalizing hint that permanently dark areas near the south pole of the moon may contain frozen water deposited over millions of years by impacting comets. Soon after Clementine, the Lunar Prospector spacecraft mapped the moon's surface from the orbit during its mission in 1998 and 1999. This data, combined with those from Clementine, give scientists global compositional maps showing the complicated crust of the moon. Lunar Prospector also mapped the surface magnetic fields for the first time. The data showed that the Apollo 16 Descartes Highlands is one of the strongest magnetic areas on the moon. Expanding the surface measurement made by John Young in 1972, the mission also found enhanced quantities of hydrogen at both poles, adding to the lively controversy over the welcome prospect for the lunar ice. The moon throws stones at us, lunar meteorites. In 1982, we made the startling discovery, a meteorite found in Antarctica, or ELHA 81005, is from the moon. The rock is a complex regolith breccia similar to those returned by the Apollo 16 mission in 1972. We have since found over 50 meteorites that, as determined from their unique chemical composition, come from the moon. These rocks is blasted off the lunar surface by impacts, then captured and swept up by the Earth as it moves through space. The lunar meteorites came from the random places all over the moon, and they provide data complementary to the Apollo samples and the global maps on composition obtained by Clementine and Lunar Prospector.